Scientists have probably cracked the mystery of space signals. In the first days of January, a new revolutionary telescope in Canada detected 13 new signals coming toward Earth from deep space. Does this mean we're not alone in the universe? Let's find out. But first of all, hit the subscription button and turn on notifications to keep up with new videos that appear on the bright side of life every day. The beginning of this year brought us some thrilling news. Astronomers have discovered 13 high-speed radio bursts coming from deep space. But the most shocking aspect of this finding is that one of these 13 radio bursts is a highly unusual repeating signal. It comes from a source located approximately 1.5 billion light-years away. Experts keep debating on the origin of this signal, but there already exists several theories which shed some light on the mysterious flashes. But let's start from the very beginning, namely from fast radio bursts themselves. These signals are some of the weirdest phenomena of the universe. They are pulses of radio waves which comes from far outside the Milky Way, which is our home galaxy. Each burst is only a millisecond long. For the first time, fast radio bursts were detected in 2007. Interestingly, astronomers who were examining the park's radio telescope archive data didn't expect to discover something so far-reaching. They were in search of new pulsars, magnetized neutron stars, but instead, they got information about an entirely new phenomenon. It was a fast radio burst recorded in 2001. Since then, astronomers have found information about 6 more sources of radio signals in the archived data from the park's telescope in Eastern Australia. And one more burst was discovered in the archived data from the Arecibo telescope in Puerto Rico. And in January 2015, scientists observed a live fast radio burst for the first time. It happened in the park's observatory in Australia. Astronomers believe that more than 1,000 of such flashes happen every day, but only a few of them get detected. However, this situation may change pretty soon. In August 2017, the construction of the CHIME telescope was finished. This name stands for Canadian Hydrogen Intensity Mapping Experiment. Yeah, it's easier to just say CHIME. This revolutionary telescope is situated at the Dominion Radio Astrophysical Observatory in British Columbia, Canada. The CHIME telescope doesn't have any moving parts. It was created to map hydrogen, the most abundant chemical element in the universe. This mapping process can help scientists better understand the dark energy which is speeding up the expansion of the universe. The new highly unusual device consists of 4 fixed 300 feet long semi-cylindrical antennas. These antennas can scan the visible sky 24/7. The telescope has extensive frequency coverage from 400 to 800 megahertz and a large field of view, more than 200 square degrees. This makes CHIME the one-of-a-kind telescope for detecting fast radio bursts. Exactly this unique device has recently discovered new signals. Astronomers hope that the telescope will be able to record more than a dozen of these radio bursts a day. It might be possible, thanks to the impressive scale of the apparatus, a dozen of these radio bursts to monitor a vast part of the sky. As soon as scientists start to get more information about these mysterious signals, they will probably manage to discover their nature. So, let's get back to those 13 new fast radio bursts that the CHIME telescope has detected. Curiously, their radio frequency is the lowest of all signals that have been detected so far. At the same time, these signals were brighter than those discovered before them. It made the research team suspect that the low frequency might depend on the environment where the source of these signals is situated. And while the most recent fast radio bursts probably don't travel from further away than others, they might be changing if they pass through plasma or hot gas on their way toward Earth. Thus, these 13 signals might have appeared in some turbulent regions of their home galaxies, for example, somewhere close to a black hole or near some high-density supernova remnants. But wait, there's another enigma connected with one of the new signals. The structure of the fast radio burst, which constantly repeats, is shockingly similar to FRB 121102, the only other repeating signal scientists have ever observed. On the other hand, the new repeater is a bit brighter than the previous one. It may have something to do with the distance, it's 1.5 billion light-years closer. Unfortunately, at the moment, the research team can do nothing but watch the region of the sky where the signals have come from with the help of CHIME and other radio telescopes. They need to figure out if single and repeating radio bursts are coming from different objects or not. Research radio telescopes. When the CHIME telescope discovered the new burst, it wasn't running at its full capacity. That's why the team is thrilled to find out how much more information they can get now when the telescope is working at full blast. Up to the present day, astronomers haven't come close to any conclusions about what causes fast radio bursts. However, there exist several theories. Two merging stars. One of the possibilities can be two colliding neutron stars. Dr. Sriharsh Tendulkar, an astronomer from McGill University in Montreal, Canada, is sure that this is the most plausible explanation. At the same time, this scenario works only for single radio signals. When the stars crash together, they get destroyed in the collision. That's why you can't see repeated radio flashes. On the other hand, the majority of fast radio bursts that have been discovered in the recent years were only seen once. After that, they simply disappeared. But what about the two repeaters that appear again and again? Well, these may have a different explanation. A black hole. Many astronomers support the theory, which is based on the participation of a black hole in the appearance of fast radio bursts. Some experts believe that fast radio bursts may occur when a neutron star falls into a black hole. Others are sure that this happens when a black hole gets hit by dark matter. Another version is that when a black hole collapses, it emits fast radio signals. These theories make sense if you know that the electromagnetic waves which create radio signals follow a unique pattern. It may mean that they come from a place with an incredibly strong magnetic field. Such an area may be found right next to massive black holes, for example, the ones which are located in the centers of galaxies. A spinning neutron star. There's also a group of scientists who think that the source of fast radio bursts may be a spinning neutron star. Jason Hessels, associate professor from the University of Amsterdam, supports this theory. He states that the source of the burst can be a rotating neutron star. Its home should be a place with the extreme magnetic environment, for example, a black hole which is sucking in dust and gas and therefore growing. Unfortunately, scientists haven't yet figured out which physics could be producing such active radio bursts. Blitzar. A blitzar is a spinning neutron star which can't bear its own weight anymore and after collapsing forms a new black hole. Theoretically, this process could produce fast radio bursts, but on the other hand, such an event means the demise of the star, thus this process can only be the source of single radio signals. Alien civilization. The origin of most fast radio bursts is entirely natural, but the existence of the repeaters makes some people believe that they are the product of an alien civilization. Those who support this idea consider the signals to be the proof of extraterrestrial activity. At the same time, Dr. Ingrid Stairs, an astrophysicist at the University of British Columbia in Vancouver, Canada, states that it's an unlikely possibility. The thing is that signals are coming from various directions. It means that their sources are located in different galaxies. Dr. Stairs is sure that several alien civilizations from galaxies situated far away from one another wouldn't have the same type of signal. Even if they had, they wouldn't use it in the same way. And that's why she deems this theory improbable. Which opinion seems the most plausible to you? Write about your ideas in the comment section below. Remember to hit the like button, share this video with your friends, and subscribe to the channel to stay on the bright side of life with us.